Hello, everyone. Welcome to the second conference after the lunch break in our data track. Today we have with us Tundu Groot, which is independent Python trainer and developer with decades of coding experience, and he will be sharing with us pro Python tips for data analysts. Koen, I give you the stage.
So, thank you, Amira, and welcome everyone. So, yes, the topic of the talk is pro Python tips for analysts. Yeah, hopefully I'm listening. Hopefully I've got an audience of data analysts now. My background is, so I'm a professional Python programmer. I've been developing since the early 80s. I've been using Python for 20 years, and I do Python development, consultancy, and training. For the last 4 days, I've been training a cohort of new recruits in data analysis and just basic Python. So that's kind of sort of thing that I do. So the idea of the talk is that, well, it's one thing to write your software, to analyze, to do your analysis. And the dream is that you kind of write your code, you do your analysis, and then kind of it sails off into the distance, and everything's kind of smooth, and everything's running fine, and everything will work kind of forever. But the reality might be more like, well, if your code is not very good, and when you come back to it a while later, you find it's kind of stuck. You can't do anything with it. Your code might get stuck. It's not very as a professional developer, I'm used to writing code in a particular way. As a data analyst, you may be fantastic in your field, either just statistics or whatever you use, or maybe whatever your other background is, financial or something like that. But you may not have the tools to write code that keeps running. So the reality might be that you write your code and after a while, it just becomes unusable. So this talk is very much about how to write code that will keep sailing, that you can keep using. This is not about doing a quick analysis where you just import a couple of bit of data and you end up with a very simple chart. This is for the bigger code. Okay. So let's go through some of the problems that you might encounter when you write more complicated analysis and more code. So what I find myself often doing, and probably the same for you, you import some data and then you need to do a little task. You've got a little problem that you need to work on. So if you've already done it, fantastic, you just type in the code. But if you don't know what to do, you do some experiments. You might go off to Google, you might go off to Stack Overflow, which is a very popular site for data analysis. No, not for data, for Python. Well, general for developers, or maybe go to Kaggle or some other. You find a bit of code, you put it in, and you put in a bit more code, and you get something working. So by the end of it, you'll have your code. So far so good, but is it? You may end up with something more like this. So you've got this whole pile of code, and in there is some useful code, but there's some code that you've copied from somewhere. You might not even remember where it is. Some things you've tried, some tests that you've aborted, and some other code that you don't even know what that is. So you can end up with this real kind of mixture of code. Then the other thing is you may end up with inconsistent code. One, you use different names, you use a different kind of way of writing your code, and it's just, you need to remember all the detail, because you've got one name in uppercase, the other one is lowercase, the other one starts with DF, then you use an abbreviation. So you end up with things to remember that, yeah, actually take you away from the job that you're trying to do, is do your analysis. You've got this cognitive overload. Your brain is full with too much stuff, because you have to remember stuff, because it's not very things that you just need to remember because your code is inconsistent. So you have to remember how you wrote your code instead of writing it and just kind of getting on with it. And of course, the other thing is you may end up with a lot of code, which becomes difficult to handle, just kind of scrolling up and down and trying to find things and change things. So you may have too much code. And finally, your code might be too fragile. maybe you've written your code in a way that if you change, but you're afraid to change it because if you make any change to it, all the code will just kind of fall apart. It just like a house of cards, it just all falls down. Okay, so some robust code would be good. So, how do we go towards the dream? What can we do? So I've got eight suggestions or solutions. The first one is to clean your code. So you can write your code, and as I said, you might end up with stuff in there with code that isn't very useful. So there's a couple of approaches. You can take your code, you can get to the end of your code and then clean it all up. Now the risk with that is, if you do that, well, once you've got your solution, you probably want to move on to the next thing. And if you wait till the very end, you don't have the benefits of having the clean code as you do your coding. You've only got the benefits the next time you use your code. Which is good by itself, because if you come back to code that you wrote a while ago, it always takes you a while. Well, for me at least, it takes me quite a while to get back into it. If there's some time has passed, some months you've done some other projects. So the cleaner your code is, the easier it is to use. So cleaning the code at the end when you're done is useful, but not quite as useful as doing it as you go along. So what you can do is you can take a step, have like a mini problem, like how do I clean that data? How do I break that column up into multiple columns? How do I do a particular chart? Every time you've solved one of those little problems, go back to the steps that you took to do that and clean it up, remove any dead code. Yeah, just make it look tidier, make things consistent. Particularly if you copy somebody else's code, you will, like a solution that you found online, you often end up with a different style of coding than you do. So clean it up as you go along, once you've solved one step, and then go on to the next step. Okay, second solution. Use some sort of coding standard. A standard helps you to be consistent. So the one that most professional Python developers use is called PEP8. And for instance, one of the suggestions is to use names that are all lowercase. And if you use a longer name that consists of multiple words, put an underscore between the multiple words. So that's the example you see on screen. Use consistent names like that. Now, you can read the specification, the standard, and try to adopt it. Try to adopt it. There's also a tool called Black. That comes from, well, you can use any style of code as long as it's black. Like Henry Ford used to say many years ago, you can have any color of car as long as it is black. So that's Black. And what Black does, it will automatically reformat your code as you do your work. Now, you may or may not like that, but it will enforce the standard for you. So have a look, do a search for Jupyter Black, and read what it tells you, gives you a bit more information, and yeah, see if you want to adopt it. Okay, third solution. Reuse your own code. What I mean by that, I don't mean just copy your code. Just don't kind of take your code from one cell to another and just kind of have 10 copies of the same code. In programming, there's the DRY principle. Do not repeat yourself, DRY. The risk with cut and paste, or with copying your code, is that if you later discover that there was a mistake in your code, or if you decide that you want to improve it in some way or another, then if you've got 5 copies of the same code, you will have to change it in 5 different places. It makes it quite clunky and tedious to then make changes, which probably means that you won't even try to improve it because it's just too much and too risky. So instead, have one copy of your code, but make it a Python function. So learn about Python functions. Also learn about loops. If you want to do the same thing on multiple columns, maybe pandas will let you do it straight away and let you do just work on a range of columns, as in a subset of your data frame if you use pandas. But if you can't do that, if you only manage to have a solution that works on one column at a time, then a Python loop will let you do the same thing for a whole list of column names, for instance. Now, if you want to get really sophisticated, but for really, really big programs, then you can also learn about Python classes. Object-oriented programming, it's another way of structuring your code, of structuring big programs, but that gets a lot more sophisticated. So that is really for writing big programs. Then the other solution is to use other people's code, which could be the generic. If you're a data analyst, you probably already use pandas, numpy, matplotlib, scikit-learn, etc. So those are more the generic ones. But there are also more focused tools for a specific domain, like for fintech, financial technology, for there's AstroPy for astronomers. So each domain, each topic has its own set of Python libraries. Or maybe a specific approach, like a particular statistical model. So a lot of that code already exists. On pypi.org, the Python package index, there is 340,000 Python packages. Not all pandas or not all data analysis, but there's a lot of data analysis packages as well on there. So yeah, have a look in there. And they're on pypi.org. The packages are also organized by topic. So I think it says categories or something like that, or catalog. So you click on that and you get a whole list of topics and just kind of look for the topic that work for you. Personally, I have been accused of reinventing the wheel, because sometimes it seems easier to just start from scratch and just write it yourself. But using other people's code, you've got often code that is tested a lot more, that has been tried in a lot of different cases, gives a lot of flexibility. So you can use pypi.org to look for other people's code. Of course, you can also use a search engine. If you want to just learn it, so the way I pick up new libraries and packages, I also learn about them by listening to a podcast. If you search for Python podcast, I quite like the Python Bytes with BYTES podcast. That will give you like 6 topics every week. There is also a specific data analysis podcast. I can't remember any for Python. There is newsletters. There's newsletters on data analysis. Maybe get a weekly newsletter, so you get a new library every week. And then when you need it, you may not remember the whole discussion, but hopefully you remember the name of the library and you can kind of go back to it. So over the months and over the years, you just build up this supply of libraries. Then the next solution particularly to make your code less brittle, to make you less concerned about breaking your code, is to test your code. So you can automate. There's ways of writing tests that are automatic, that run automatic. So you write your test either as part of or separate from your notebook, if you use notebooks, or if you use a script, you can keep it separate again, and you can write a bunch of tests that will run through your data analysis code and check that everything is still the same. This can be useful for some very complex manipulation that you're doing. If you're building up your code and you need to do the same test again and again because it takes you hours and hours to actually get it right, then it might be easier to create a test first that you can just run, that will do the testing for you. And then you don't have to think about, well, okay, what are the steps for me to do my testing? Instead, you just run your test, and that is called the testing steps baked in. So have a look for Jupyter unit testing, maybe data analysis unit testing, but Jupyter unit testing gives quite a few results. Have a look for that, and that will give you specific techniques. The other one, so let's say you've got something working, you've got some analysis that you've done, you've got your notebook, and it's working, but actually you want to improve it, you want to tidy it up, as I suggest, tidy up as you go along, you want to add something to it. Now the risk is that as you make your changes, that you actually break something. So then I guess you could create a new copy of your notebook and another copy, etc. That's one way of doing it, and at some point you lose track of your changes, because if you break something, you want to go back to a previous version. Otherwise, you could have wasted. You're going to waste hours to try to figure out, well, what did I do and where did I break it? So there. The technical term for that is you use version control. So you've got multiple versions, and you track, as in you keep the previous version, the version before. Every time you make a change, you save that as a new version. Now the problem with if you're using plain scripts and you're just using pandas but you're not using Jupyter, then version control is fairly straightforward. You use on Git, that's the most popular tool, Git. You might store it on GitHub, although there's also GitLab and other ones. But yeah, you may just store it locally. So all of that works, but the problem with a notebook is that a notebook contains your code, but also the results. And what version control software does, it compares the old version with the new version, and it just remembers the changes. Which is really good, because then you can see, well, how your analysis developed, how your code developed as you were working on it. You can see the changes from one version to the next. But if you use it as a normal notebook, in between there will also be all the results. So when you save your notebook, all the output that you see between the cells that contain your code, that also gets saved, which is lovely because you pull it back up, and with the next time you load it, you can see what you did before. However, if you compare that to the previous time you ran it, there could be a whole lot of changes that will then also be flagged and also will be saved. And it's just going to pollute this lovely history of just the changes that you made. So there are some solutions to this that will remove the results before it goes to the version control. But yeah, be aware of that. You can't just do version control on the notebooks just using Git. Doesn't work very well. So search for Jupyter notebook version control and you will get some solutions on that. Some specific solutions then. Okay. 2 more to go, 2 more solutions. So use the best tools and know how to use them. First of all, use your brain and keep learning. So when you find an answer to something that you didn't know how to do yet, cut and paste it, get it working, but then take a couple of minutes to figure out, well, what is actually going on here? What happened here? So that you learn as you're doing it, otherwise you're going to end up with all these solutions that you always have to go back because you've got no idea what you're doing. Maybe learn some Python, because that's in the end, that's the underlying tool below everything that you're doing. Every now and then, learn a bit more pandas, learn a bit more NumPy. Just keep learning the tools that you use every day. Also, quick comparison. So you may use Jupyter Notebook. If you write really big scripts, then maybe look at using an IDE, an integrated development environment. So on the left on your screen, you see a notebook. On the right, you see what it looks like in your integrated development environment. So it means you're just working on your script, and instead of seeing the output in between every step, between each bit of code, you will just see the output at the very end. It's a different way of working, but it can actually be quite helpful to write better structured code. So yes, if you write really big complicated code, then look at integrated development environments. Okay, finally. So have you ever written, created a cell and then another cell, and then you were working on the second cell or a bit of code and you couldn't run it because you'd already deleted a column? Like top left hand corner, you see read a CSV, drop a column, drop the same column again. I mean, normally it would be the same cell running twice, but I couldn't show that. So run the same cell again, and it gives you an error message because you've already dropped the cell. So instead, there's two suggestions I've got. One is towards the right, where you read the data into something like a raw data frame or something, and then you create a new data frame from that with the where you drop it, for instance, where you make the change. And that one you can run twice, as I'm showing you there, and that just worked. Or you can create one cell that does all the work, like I'm showing at the bottom. I'm using chaining there to pull it all together. I'm using brackets to make it a bit more readable. So you can take a whole bunch of steps. Here there's one step, well, two steps. Read it in, drop it. But then you can do all your tidying in one go. And that cell you can run again and again. If it's a really big data frame or a lot of data, then you probably want to read it once, maybe put it under a temporary name like raw or whatever, because otherwise you have to read the same data again and again. If it's smaller, then it doesn't matter quite so much. Okay, so quick summary then. The problems we're dealing with is messy data, messy code, inconsistent code, big code and fragile code. And then I've shown you all the solutions. So we got the clean up straight away, use coding standards, reuse your own code, reuse other people's code, test your code, use source control, use the best tools, and be able to rerun your cell so it doesn't feel quite so fragile. In the table, I've tried to give some idea of which solution addresses which problem. Right, that is my 20 minutes. So thanks for your attention. May your code have a bright future, not just today, but a bright future. And finally, any questions?
Yes, we have a question.
Okay.
So, have you ever seen AutoPip 8? And if so, do you think it's okay to use? I've been using it in my Jupyter notebook, but not sure how good it is.
No, I haven't, to be honest. I mean, there's a lot of different tools out there. I'd be happy to have a look at it for you. So I don't, Mr. or Mrs. ASDF. So feel free to kind of contact me, and I can, I can look it up. I can try to give you my impression of it. The fun thing about conferences, etc., I always learn more stuff from it. So just send me a message, but it's not something I've used myself.
Yes, and we have another question. So you have mentioned using other people's code, right? Which could be challenging
Yes.
sometimes to understand other people's code. What do you suggest in that case? To reinvent the code or use the old one?
Okay. Well, reading other people's code can be very useful because you might learn something from it. So I think it, like with many of these things, it's a balance. You could spend hours finding some code that you could write in a few minutes. So I don't think there's no, the answer, of course, it depends. But I think it's worth, if you find a library that already exists, that's got a lot of stars on in GitHub or wherever it's hosted, that a lot of people already use, then there might be some documentation, etc. So that's also how you can use other people's code. You can also use other people's code to try to pick up some tricks from it. So maybe it doesn't give you the whole solution, but maybe it'll give you some of the solution. The other thing you can do is you can take somebody else's code and run it by itself. So at least you can see it running away from your big analysis, but just run it separately. And if you can get their code to run, then you can start playing with it. So you can take all the code, put it in your code, and try to run it. But then you're working with two problems at once. You're trying to understand the code and trying to make it work with your code. Instead, separate it, run it separately, and then you can almost evolve it to fit in with your code.
Really great
Okay.
answer, Koen.
Mhm.
And I don't think we have any other questions.
Okay. Okay. Well, thank you, everybody,
Thank
and
you for
enjoy
the
the rest of the conference.
thank you for the presentation.
You're welcome.
Bye.
All right.